Uh, yeah, hi everyone. I'm just gonna jump into it. My name is Samkele Ngcefa, and I will be talking about integrating species distribution modeling with thermal physiology to measure the climate change response of an important recreational fishery species in South Africa. So unlike most areas around the world that are experiencing straightforward or uniform warming or cooling patterns, South Africa is faced by dual threats because of the nature of our coastline being influenced by multiple current systems and oceans. These are expressed in things like the cooling that is observed in the south and west coast, driven mostly by upwelling, the warming that is observed in the subtropical and tropical east coast, and generally a high thermal variability that is observed in the southeast coast. And what is expected to happen is that we will see impacts on coastal fish populations. This may include range reductions and productivity declines. And for the marine shore-based fishery, what can be expected to happen is catch declines and a general decline in the fishery's economic output, which may call into question its long-term sustainability. So if we want to then mitigate these issues, we first need to start thinking about quantifying them. And this is especially important considering the complex socio-ecological dynamics of the fishery and the associated data and management limitations. So we set out to do just that, which is to quantify these responses. And the first step was to build an ecological niche model using Maxent to quantify the current and future distribution of the species. This was to answer where the species will occur in response to climate change. And then we followed this up by then quantifying the thermal physiology of the species to answer how well it will perform. And the species in question here is Diplodus capensis, the blacktail sea bream. It is a Southern African endemic species, spared, with two distinct populations, one in Angola to Namibia and another in South Africa to Mozambique. It is a shallow water species tending to inhabit shallow inshore reefs in both its subadult and adult life stages. But as Nikki showed earlier, they do tend to sometimes use estuaries, especially in their younger life stages. The species is an important species in the fishery in that it dominates catches, and this alone would make it a priority species for research because it supports many livelihoods through the fishery. Again, the species is very well studied, which means that the insights that we will draw from the study, or that we have drawn from the study, feed into an ever-growing body of knowledge on this one species that will lead us ever closer to better climate adaptive management measures, not just for the species itself, but for the fishery as a whole, as there are many species that are similar to Diplodus capensis exploited within the marine shore-based fishery. So to build the model, which is our first step, we needed two kinds of data. We needed occurrence records and environmental data. The occurrence records were obtained from three sources: the Global Biodiversity Information Facility, GBIF, the Rock and Surf Super Pro League, and the Oceanographic Research Institute's cooperative fish tagging program, or ORI-CFTP. The latter two of these sources are recreational fishing. The data comes from recreational fishing activities, which is quite great and relevant to what we're doing here. And the environmental layers were obtained from publicly available databases of remotely sensed satellite data. And these are namely BIO-ORACLE and the Copernicus Marine Service. So with regards to the occurrences, we found a total of about 799 occurrences after spatial verification. And they were found to occur in all four biogeographic zones around our coastline. And this is the South Africa-Mozambique population. We haven't included the Angola-Namibia one because they do have some genetic differences. the points are there. So it starts there in the west coast all the way up to Inasoro in Mozambique. And when we overlaid the bathymetry data that we got from the satellite data sets, we saw that none of the occurrence points occur beyond 50 meters of depth. With regards to sea surface temperature, we got 3 variables: summer, winter, and annual sea surface temperature around the coast. And there was a clear pattern throughout the variables of cooler conditions in the west coast, transitioning to warm temperate in the south, and then subtropical and tropical in the east coast. So there is a general warming pattern as you move from west to east. So we built multiple models using sort of like a saturated model and several reduced models, but the one reduced model that performed best and the one that we used for downstream analysis was one with summer, winter, and bathymetry. These are the matrices that we use to evaluate the model. AUC was the main one, but we also looked at omission rate, jackknife of AUC, and the jackknife of training data. The model then gave us a prediction of the current distribution of the species. And we see that it is mostly within the warm temperate and the subtropical biogeographic zone. And this is a binary threshold, so it's like probability of occurrence beyond 50%. And we find that the species is predicted to occur from False Bay, which is just next to Cape Town. They're marked by the green arrow in the west coast, to St. Lucia, just north of Durban, also marked by the green arrow. And we are here. So what we then wanted to do was to look at the future distribution of the species. So we then used SST trends within the region to project temperature forward to the end of the century, 2100. And then we use these temperature projections to then feed into the Maxent models so that it can predict a future distribution for our species. And what we found is that the warm temperate subtropical distribution is maintained, however, with range losses, especially in the west coast, amounting to about a 22.9% reduction in the total range of the species. And we thought that this, because summer SST was quite important when we were evaluating the model, we had a look at what we saw in terms of trends in summer SST, and we see that there's very intense cooling patterns there in that west coast area. This is a per decade cooling trend since 1981. We also see some warming in the east coast and some cooling here in our region where we are. But I think you'll notice that even though we're seeing contractions in the edge of the species distribution, the middle of the species distribution is stable, and despite the cooling trends that I just showed you. So we then asked ourselves what could be causing this? Could the model be missing something? This is when we started, looking at this area specifically. And thanks to the RASSPL data that we had, we were able to use the catch per unit effort data there to sort of determine a core area of relative abundance for the species. And we found that it is actually here in this area where we are now. And we used that information to go out and catch fish in this area in Port Alfred, same place where Notley caught her fish. And we brought them to the diffs in Grahamstown, and we ran intermittent flow respirometry trials on them. And basically, I don't know why the videos are not playing. I had some really nice videos. Anyways, it's fine. Just imagine the fish moving there. Those fish, they're supposed to be moving. So we ran respirometry trials on those, on 20 individuals. And this was a simple process of just taking the fish, putting it in a chamber, acclimating it to your test temperature, and then measuring a standard metabolic rate and maximum metabolic rate. What we got out was a population level curve for SMR and MMR, and what we saw for SMR was an exponential increase with temperature, and then for MMR we saw a linear increase with temperature. So that means that for MMR, we could potentially, if we moved beyond the 24 degrees, we could potentially see plateau in that MMR value. But the main thing why we measured these was we wanted to calculate aerobic scope, which is the amount of energy available to the fish for it to perform its basic life functions. And what we found with regards to the aerobic scope of the sample population is that it had a biphasic relationship with temperature, and that it's sort of like it's curved with a peak at 16.89 degrees. What we are also able to calculate is Page's temperatures on either side of the peak, which is Page's temperature is the temperature at which physiological performance starts to become suboptimal. And what we found is that on the lower end, it's 13.74 degrees, and then on the upper end, it's 20.05 degrees. This is quite similar to another paper that did a similar measurement of physiological performance, but on heart rate. They found that the Arrhenius breakpoint for heart rate was around 21 degrees, which may indicate that around 20 degree Celsius area is where the fish starts to experience physiological stress. So it was a good confirmation for us. So seeing these Page's temperatures, we then sort of approached it in a sort of novel kind of novel approach that hasn't really been applied here in South African waters. We looked at the frequency of Page's temperature exceedance based on the SST data that we had. So what we found, I'm going to try and speed through this one. What we found was that for the lower Page's temperature within the core area of relative abundance, there was a spatial and temporal variation, with fish being more stressed in the southern part of the core area and during the warmer months. And this is thought to be resulting from the upwelling cell that is in this area here. And for the upper Page's temperature, we didn't find a spatial variation, but we found that temporal variation as well. Again, in summer, fish being more at a higher risk of thermal stress. So in all, what does this tell us when we now synthesize the whole thing? We see that the fish is likely to lose about 23% of its range on the edges. But despite the temperature shifts within the middle of the range, we're not seeing anything, but we do believe that performance will be compromised. And when looking closer into this, we see that there are performance dynamics with a peak at 16.9 and Page's temperatures of 13.74 and 20.05. And when looking at deeper into that, we see that the frequency of exceedance of these Page's temperatures has a spatial-temporal variation to it. And what this means for recreational fisheries is that if you just look at for instance, the range losses themselves, we could see declines in catches, especially in the Western Cape, where people tend to rely more on fishing in the coastal communities. And the declines in productivity within the core area could sort of mask the effects of climate change, because we're not expecting to see range losses, but we will be seeing productivity declines, which then leads us to think that we need to have a more targeted approach to managing these fish along the coast, and not just a one size fits all. Certain areas will be more vulnerable than others. I would, in fact, I'll skip this slide because I do want to open time up for questions. So yeah, thank you very much. I hope.
Looking for a pithy question and a pithy answer. Anybody?
So you have some instances where you get such cold water coming in that you get fish kill. Yes?
Yes.
And so that's a population level change when you get the fish kill. How do you see that comparing to climate change? Because you still have population level responses. How long does it take a population to recover from a cold kill? And then how might that be kind of projected forward to climate change? How adaptable are the fish?
Okay, so there was an earlier talk, and I have addressed it in the bigger work that you've done here. We see that the amount of heat waves and cold spells along our coast is increasing in frequency and intensity, and that we expect will cause greater risk of thermal stress, especially within this area. And what we've also seen is that, what we've also seen is that if these heat waves and cold spells co-occur, like for instance, if you have a heat wave and then followed by a cold spell, that's more dangerous for the fish communities. But in terms of that being linked to climate change, that work has been done, and we see that there is a trend of increasing variability, especially along this part of the coast and the south coast.